This conference will now be recorded.
Containers are everywhere, meaning instead of people creating VMs, people are generally creating containers. One for isolation, instead of updating a whole machine, they can now just kill and just build and destroy their container, their environment. You can use Docker is very popular. It used to be free, but Docker was losing money and they were getting ready to go under, and they needed a way to save themselves, so now they charge you for Docker. So now that's one thing. Another one is when it comes down to the different type of containers, Docker isn't the only thing inside of as far as containers. So if we go to the CNCF landscape, all right, I'm gonna blow this up some. Um, I don't know if you saw that number up there. Hold on. You see that, right? The viewing cards here, the market cap is 15.8 trillion and funding of 27.8 billion. And they're talking about here on these cards. But the way these cards are laid out, this is what most people are running to now as far as like where's the industry going and what are the standards, right? So here, if we look here, we can see how it's broken out: databases, stream messaging, service proxy, container runtime, and cloud native network. So if we click on this particular card where we're talking about container runtime, you can see there's container D, there's cry.io, or CRI-O, however you want to say it, Firecracker, gvisor, Kata, LXD, Open Run or Open Run C, Singularity, Smart OS, and Wasm Edge Runtime. And each one of these different projects, you can see that where they have funding at, right? You can see where they have funding at, right? Firecracker, Amazon Web Services, 1.7 trillion, Google, 1.9 trillion, so forth and so on, right? All right. And you can see Docker's not on here because it's not open source anymore. So that's why you don't see it on here, right? So now if you go over here to docker.com, you can sign in. They have their pricing here. But you want per Docker desktop, unlimited public repository, Docker engine for Kubernetes, limited to image pools per day. You get $0, $5, $7, and then $21. A lot of people uh are using Docker. They got kind of soaked up with it, so they didn't have a choice. So they had to pay for the services and stuff they had been using for Docker, right? All right. So what? Why are you telling us this, Tamika? Well, I'm telling you this because Docker used to be the baseline um for Red Hat. It's no longer the baseline for Red Hat. They pulled it out about. It's been about 2 years now. Yeah. Well, yeah, because we were in France when they were talking about it. Tim actually gave a talk on this. Tim Surowitz. He was the young fella that we did the talk with on was it last Friday? Don't get me the line. Last Friday or last Wednesday? I mean, last Thursday? I don't remember. We'll go to here the videos. Let me see. When was Tim? Everything Kubernetes a week ago. Right, here's Tim and the talk on Kubernetes, right? So we did a talk on Kubernetes and we were talking about the runtime and so forth, but Tim also did a talk on he did it in France. Let me see if I can find it about container runtime. And he was talking about how uh the containers were being contain where the containerization was going and what was going on with Red Hat and why they pulled out. The why, right? So why did Red Hat, and you can type this in, why did Red Hat get rid of Docker? And you should know this, so you can then understand. See right here, December the 15th, 20, when Red Hat launched OpenShift 4 and RHEL 8 around 2 years ago, we started down the exact same journey. We moved from Docker, right? So they talking about their move from Docker. And one of the biggest things was there was slow development for the Docker container, the security issues around it, some basically some dependencies as well too. And they go on to talk about the why in here, so you can look that up. I'll post this in Slack as well too. So for those that are just curious and interested in the why, I'll post this in Slack. I'll post it in the RECSA channel. Why removing Docker? And I'll post it. There you go. All right, so you can check it out there. All right, so let's get back to it. So in this class, this chapter 13, the goal is to talk about basically Podman, is what we're doing, and explain what a container is, install the container management tools, how to inspect a container. You have to remember that Podman runs just like Docker, so all the things that you're familiar with when it comes down to using Docker and Docker commands are the same here. And again, checking and so forth. We may go through the quiz tonight. We may not. It's going on 8 o'clock now, so I don't know how much time I'm gonna have. Right. All right. So before we get started, I'm just gonna ask some general questions. I just want to see some feedback. Who all has played with containers in here? You could just put a 1 in the comments so we can see who's all played with containers. Not everybody at one time though. Oh, Tara, you the only one that's played with containers? All right. Okay. Well, containers is a new thing. Awesome. All right, let me look here. Let me get my screen up here. I don't think my Docker is running. Oh, it is. All right, cool. So let me give you an example of this. I have Docker on my machine. Uh, Let me do this. Let me make it bigger. Let me change the font size. I think you can see it, but I guess I can make the font bigger. Export settings. You said, can I make my font bigger? Where are you at? Text, window, tab, shell. I don't see where I can make my font bigger. That's okay. But I think you get the gist. All right, Mario. All right, cool. All right, so if you're on your Mac, you can install Docker. You can actually do a Docker download, right? Right here. And depending on what chip you got, you can install Docker Desktop. You don't have to install Docker Desktop, but there's just a regular Docker you can install. All right. And download and install. And then on Windows too. Right. Let me move this over. All right, cool. All right, so one of the things like I want to do, if I want to see what images are stored on my machine, I can do a Docker images. Oh, it's not running. I didn't think it was running. Run it. That's not what I want. Do, 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 do. I know I have Docker on here. And I don't know why it's not coming up, but let me go to my services or my applications, I should say. And let's bring up Docker. Now, if you're studying the Linux stuff, um, there's no way that um, you're not gonna not play with microservices, as we like to say, or there's no way you're not gonna. It's not finding my Docker on here. There's no way that you're not gonna have a there's no way you're not gonna have to be involved with Kubernetes and so forth. And that's when you're really gonna start playing with Docker from there when you're playing with Kubernetes. But it's telling me that my Docker daemon isn't running, and now it's acting like Docker's not on my machine. Okay, so now let's fix that because I know Docker is on here. Oh, it kept asking me to update, and I never did. Let's go back. Let me see. Can I do a brew install? Uh, I'm just curious. In the meantime, in between time, while that's going on, we'll go back over here. So I was going to try to show you some Docker stuff. Yeah, there we go. All right, so here they're talking about what a container is. So let me hop down here to the picture. I think they do a lot of explaining up top versus what you can see. So on your laptops, right, or if you're using EXI, 9 times out of 10 you probably install some type of and here they're showing a type 2 here, right? And when I say type 2, they're saying, hey, here's an operating system, and then here's some hypervisor, and then we run a VM on top, right? So what's common between all of these is this, the operating system and then this hypervisor, and then we have this VM that we have here, right? And that's what they're showing here for virtualization. Versus if we have containers, basically we could isolate our runtime here. So, and containers come in different flavors. Like it could be an Ubuntu container, it could be a Windows container, it could be a CentOS container, or what have you, whatever operating system or whatnot. So that's where you're at when it comes down to containers, right? Versus operating systems. So, but let's get into the why, right? So here, containers provide many of the same benefits as virtual machines, such as security, storage, and network isolation. Both technologies isolate their application libraries and runtime. But here's a trigger. If I had to update just the underlining, let's say like there's something wrong in a container, there's an issue with the container, I can just update the container, right? And one, I'm gonna get a quicker speed. But here, uh and the other thing is too, well, it's a misnomer. Some people like to run one service per container. um, and when I say that, I mean like if I'm building an FTP server, I'm just gonna containerize the FTP server. I'm not gonna run FTP and NFS on the server, right? So people like to separate the services. You could do the same thing over here, but these become very size. When I say that, then you start talking about sizing over here, right? So you can have a 24 gig uh, a 24 gig VM. You should not have a 24 gig container. That is not a container, all right? All right, so here they said containers and virtual machines are different in a way they interact with the hardware, right? So with virtualization, we all know there is the operating system and the kernel is involved, right? So the kernel is again your friend, right? If you ever want to have a long-standing career inside of using Linux, uh, start understanding embedded kernels and how kernels work and so forth, you'll never have to worry about nothing, right? Because it's the bread and butter of how everything works, how everything communicates with each other. So here they show that enable multiple operating systems to run simultaneously on a single platform or single hardware platform, uses the hypervisor to divide the hardware into multiple virtual hardware systems, allowing multiple operating systems to run side by side. And this is virtualization, and requires a complete operating system environment to support the application. Now we're going to compare that to what we have here with let me see what's going on over here. Yep. What we have here with when it comes down to containers, they run directly on the operating system. So if you notice here, we had a hypervisor, and that hypervisor and then its operating system, we have another layer, right? Here, the actual container is in direct contact with the operating system, right? So again, when we're running it directly on the operating system, this enables applications to stay lightweight and run swiftly in parallel. In other words, if I needed to access a a device, or if I needed to access um, a storage, some type of storage, I can get access to that quickly. Where here, I'm going as a VM, I'm going to talk to that hypervisor. The hypervisor then has to have drivers installed in as a baseline that recognizes this operating system, that recognizes whatever hardware is underneath that, and then present it back up. So you can see how convoluted that can get. You can have something that in a hypervisor where the operating system itself recognizes the hardware, but the hypervisor doesn't, right? And that has happened plenty of times before. Right? The other one is share the same operating system kernel. Isolate the containerized application process from the rest of the system, and use any software compatible with that kernel, right? So here they're saying isolate the containerized application process from the rest of the system. So here we can isolate the applications here. And here's the supporting files for the runtime, right? So that's where we're at with that. And then require a fewer hardware resources than virtual machines. So in other words, we strip this out. We won't have to worry about this piece right here, right? The hypervisor, right? We can talk directly to the operating system, right? So there's that. All right. So now they're gonna get into, and this is I hope my machine, I should have it up. Here is where we get with Red Hat Linux. When you start talking about containers, you start talking about namespaces. And this is also what we start talking about when we're talking about Kubernetes. Kubernetes talks about namespaces, right? But that's how, and Docker does as well too. We're talking about namespaces. So the namespaces are for process isolations and then control group. And let me see if I can find a visual diagram of this. Uh, Visual namespaces, Docker container picture. Let me see if I can find uh, a visual thing here. That's the host. Yes, yes. I want to see the namespaces is what I want. Okay. Well, this is close enough, right? So, and this is from a perspective of Docker. We have Docker, and then you have libvirt, which is a driver. That's your virtualization. That may be it. Is libvirt the networking driver? LXC may be the virtual driver, and system D spawn, right? But then they talk about what's inside the kernel that allows that Docker container to talk. The Cgroups, the namespaces, Netlink, SE Linux capabilities. They got App Armor. But here we go. Namespaces. Docker makes use of kernel namespaces to provide isolated workspace called the container. When you run a container, Docker creates a set of namespaces for the container. these namespaces provide a layer of isolation, so we're isolating. And then they go on to show you the actual namespaces: the PID namespace, the net namespace, the IPC namespace, the MNT namespace, and the UTS namespace. And they give you what each one of those actually does, right? And so there's other namespaces here where you can see here we got mounts, we got networks, host names, interprocess communication. And then they go on to talk about we have resources isolation and file system management. Docker daemon handles start and stopping these processes. Whereas C groups, what Docker has, and I'm giving you from Docker, and we'll go back and look at how Podman works. Docker also makes use of the kernel control C groups for resource allocation. And you can, let me see, C groups, rel, because you can create C groups. Let me see, which one is this one? That's for Red Hat 7. Let's go back and get Red Hat 8. Um, this will work. Let me make it smaller so it makes sense. All right. See, control groups is a Linux kernel feature that enables you to organize processes into hierarchically. I screwed that up. Order order groups, C groups. The hierarchy control groups tree is defined by providing structure to the C group. So when you're looking at that sys on your system, and let me see, do we have one open? Let me see right here, and then go in here. And if you sudo to root, um, oops, awesome. Not now. Space. There we go. If you do a ls minus l, you'll see that file system sys. So if we cd over to sys, oh, it won't let me. Oh, I know it is sys. And then we see the systems here. You see the kernel, module, power, and so forth. So let's go back over here. And here they're saying they have the file system, the virtual file system mounted by the default sys file system C group. It is done manually by creating and removing subdirectories in there, right? So then they also go on to talk about the different versions of control groups. When would you ever really use these? um, I think you get into using C groups and namespaces if you start playing around creating, working with SC Linux, creating different groups for like you need some type of isolation for an application, like a specialty project. Most people take the stuff right out of the box as default and they don't do any manipulation um, from there. And then they go into what are kernel controllers, and I'll send this over. I'll put this inside of what you call it, but inside of the Slack. But just I just wanted you to have this information just for your own edification, right? Right. Namespaces are one of the most important methods of for organizing and identifying software objects. A namespace wraps a global system resource in an abstraction that makes it appear to process two processes within the namespaces. And so they talk about the different. We talked about these right here, the control groups and the namespaces. And I'll put this in there inside of Slack so you all can just have it as a reference. It's not something that you need, I would say, like dwell on and like really start diving into, but it would be an interview question. Somebody would ask you and say, what is a namespace and what is a C group, and how are they important to Docker? How are they important to a container? Somebody would probably ask you that, right? And they'll probably keep digging if they're real nitpicky. They'll keep digging on that, right? So I posted that inside of Slack. And I have not checked the questions. Hold on. All right. Let's see. Is there a difference in performance? I think you were asking, was there a difference in performance in a virtual machine and a container? Yes and no. Yes, there's a difference between a difference in inside the performance if you don't take a Docker container and make it 24 gigs and try to run it as a container, right? If you try to run it as, I mean, a Docker container and run it as an application, I mean, a VM, then yeah. So, creating a 24 gig VM, I mean, 24 gig Docker container, and then trying to spin it off that way. No, but there is a difference in inside of it, because you can set a Docker container to spin up really, really quickly versus like a VM. You may have multiple things that are on there, multiple services running. You can make a minimal install, but I even think a minimum install on a VM, I think the lowest you can get is probably maybe anywhere 300 to 500 packages, and you still need all these other processes to get it up and running. Like if you're gonna manage it with SSH or something like that, and I think SSH by itself has like 100 or 200 packages or something like that. Like as far as dependencies, not the SSH package itself, but the dependencies. So yeah, it could get big. It says are parallel software an example of contain parallels? You talking about parallels from the Mac itself, like the parallels, the actual, that would be an example of virtualization. What you're talking about is this parallels. Uh, hmm, this software, right? This one, right, is a fast and powerful application for running Windows on your Intel or your M1. So it would be similar to VirtualBox, right? So basically, it's, to me, that's like virtualization. So you have to have an operating system. If we go back to this picture here, uh, where's my picture? If we go back up here, what you have is an operating system, and then you throw something on top, which is your hypervisor, and then you put this on. Versus parallels would be, I have my operating system. I mean, without parallels, I have my operating system, and then I'm just gonna throw something on top of that. Make sense? All right. All right. So planning for containers. All right. So the keyword that you need to take out of here, that's gonna run with you right here, is containers are typically temporary or ephemeral, right? Temporary. How about that? All right. The reason why is I should be able to spin up an application, take down an application, spin up an application, take down an application, right? That's what we want to do with containers. Let me see if I can. Is it running? Let's see. Nope. Let me look and see. Where is my Docker at? Because I want to do a Docker pull on some stuff, but don't look like it's on here. Let me see. Um, Docker Mac OS, and I can do it on the Windows on this Linux box, but I want to do it on both places. Um, I don't know. Is this the M1 chip? Let me look. I'm installing it. Hold on. Well, it's an Intel chip. And it's downloading. All right, cool. All right, so now back over here where they start talking about this, it said you can permanently save data generated by a runtime container in a persistent storage file, but the containers themselves usually run when needed, right? So with Docker, they have what they call a Docker file, right? So let's just give a Docker file example. We're going to keep it simple. I'm not going to get too fancy. Let me see if someone got a good example. I'm just only looking for examples. Don't want to join your mailing list. Just want an example so we can just kind of talk through it. Okay, here we go, right here. All right. So, there's always a baseline image you're gonna start from, and in here for this one, that line from Alpine 3.4, that's their baseline image that they're using, right? And then they're telling you the version that they're gonna start that they want to use, and then they're gonna say, I want you to run basically a command. And because it's Alpine Linux, this is the command on Alpine Linux to update, to add packages. Right here we're adding vim and we're adding curl. And then once we have what we want in our basically our baseline image, you can see here they're doing a Docker build, and this -t is they're tagging it right here. This is the tag that giving it plus colon version 1 basically, right? So they're gonna do a Docker build on that, and they break that down on their Docker build. And then they talk about they show here how it does the Docker build, installs everything, and creates that image, right? We have that Docker image. Once we have that image, then we need to take that image, and right here they're just logging into it right here. They're running it, and it's not detached. They're logging in interactively with a bin-sh shell, and then they're probably gonna check to see if vim is installed and then curl is installed, right? And then another thing, once you do that, you need to show on it that it was previously ran, right, with Docker images dash a. But now we need to push this Docker container to somebody's repository. Now let me see if they got that where they're pushing that, doing a Docker. We tagged it already. Now we need to push it to a repository. Let me see. Let's do this Docker push. Oh, they don't have it on here. They don't have a Docker push on here. So let's go back and do a Docker push. Let's see. Um, let's see, Docker push example. Now, what's cool about GitLab, GitLab has its own container registry. So here we have a Docker push, whatever options that we want to pass. And you can see what's in brackets, right? What we say, this stuff is in brackets or optional or mandatory. 9 times out of 10, mandatory, and then the name, and then the tag, right? Options and so forth, right? So here's some of the options, right? Options is options, but we know name, we got to give it a name and a tag, right? So we got to push it somewhere. So here we're doing a Docker container commit, whatever the Docker name is, and then we tag that, and then now, well, here they tagged it here too, right, to this registry right here. That's the registry, and then they do a Docker image push, right? So we need to create it. We need to whatever we want to put in there. Once we figure out whatever we want to put in there, then we need to um, then also tag it, commit it, and then once we commit it, then we need to push it, and we need to push it to our registry. So once we get it in our registry, then we can share it out with others, right? And that registry could be local to your box, or it could be to Docker, or it could be inside of GitLab. And let me show you that. I may need my phone to log in. Oh no, I don't. Okay, let me go to my own little personal set of projects, and then let me pull this up. Right, here's my GitLab, right? But over here, there's a registry. So I can have an infrastructure registry, a container registry, a package registry inside my GitLab. But I have a container registry. And then if I click on here, you saw I have 9 tags, right? This is old, right? 11 months ago, right? So then I have my containers that I pushed up here, right here, right? I committed. I really want to keep them down around about this size, right? You can see I started off really big and I started stripping out stuff. Just kept stripping out stuff, right? Keep stripping out stuff till you got it, till you get it down, right? Well, I added stuff here, but I stripped out some stuff. But when you start adding Terraform inside of your container, you start adding any other packages, they're just gonna blow your packages up. So that's where that comes from, right? So that's my registry. So if I look here, you can see I have a registry. I have my image, my manifest, my digest, so forth, right? And I can use this container now if I needed to, right? All right, so here they're saying running containers from container images. Containers are run from container images, and that's what I just showed you with the Alpine. And then they also say that remember that this serves as a blueprint for creating containers. So that image, you may have an image that you want to have, like say a good way to test out stuff is, say you want to test out Terraform, but you don't want to install it on your local box, right? There's a Terraform container that you can download, and you can say, okay, whenever I use Terraform, I'm just going to run this container and I'm going to do everything out of that container. And when I get done, everything is destroyed because your container, once you destroy the container, whatever you did in that container, it goes away because you're spinning up a new environment every single time, right? So here they start talking about container images, package and application together with all of its dependencies, system libraries, language runtimes, programming language libraries, configuration settings, and static data. Container images are unchangeable, or what we consider immutable infrastructure. And in this case, files that include or require code and dependencies to run the container, right? And then they go on to designing based architectures, and containers are built according to specification. And here's the OCI. We talked about this before. You all seen this before, the OCI for containers. And I'll put this link inside of the chat. But the OCI initiative is pretty much the initiative that everybody follows when it comes down to creating the container, securing the container, of pretty much your baseline of what a container should and should not be. And I'll put this inside of Slack as well too. How's the information so far? Are you okay to keep up? I'm not seeing any questions so far. All right. All right. So OCI, right? The government follows this. A lot of people, when you're going on interviews, they'll ask you about what are your best practices that you follow when creating a container. What are you looking at? Really start looking at, when you're creating your containers or creating your environment to in which containers will run in, look at best practices for that. So we can click here, um, and they just kind of go a little bit more into it. And then they got a community, and then they got a GitHub as far as the initiative goes and so forth. So you can look more into this afterward. I won't spend a lot of time on this. But let's go look and see what they got on the blog. They had a summit. Let's look and see. September the 30th, they had one from 9 to 5. The OCI Summit gathers the open container community around the open industry standards and container formats and runtime. And you saw that on this runtime here when I was talking about it here. If you're in O'Reilly, it uses Kata containers. We did an interview with the guy that created this Kata containers, and O'Reilly ended up buying them. So those sandboxes that you spin up are Kata containers that you spin up inside of O'Reilly. Canonical, you can see here, LXD is their container. You can see there, right? So let's get back to where we were at. All right. So here, you should install a you could install a complex software application made up of multiple services in a single container. For example, you might have a web server that needs a database, and so you may put them together. But a lot of people like to separate the web server and the database. They like to run one service per container. A better design runs each component, the web server, the database, and the messaging system in separate container. This way, updates and maintenance to individual application components do not affect each other. So suppose you had the web server, the database, and the messaging system all in the same, all in it on the same in the same container, right? Well, what can happen is you update the operating system of that, or you make some config change, and then it takes down every last one of these services, or the database may not be compatible with that particular update, right? Anything can happen. But if you separate these out, now you can update this, you can update this, and then you can update this. And so you're keeping the processes and so forth isolated. So now I've been showing you, Docker, they're using Podman. All right. A good way to start learning about containers is to work with individual containers on a single server. And that's what they're going to do. That's what we're going to do in the class. Podman, which directly manages the containers and container images. I guess it's this Scopio, Skopeo, which you can use to inspect, copy, and delete. So inspect meaning I want to get something out of that container. I want to copy something, right? I want to delete, right? And then builder, which you can use to create new container images. So we can create container images with builder versus before we were using Docker build to create we use the Docker file, and then from there we created an image, right? And it tells you that these tools are compatible with the OCI initiative, right? They've been working on this for years. Using builders to construct your own container images is beyond the scope of this course and is introduced in Kubernetes container Kubernetes DO 180, which I don't think is I don't I think that one is that may be free. That one may be free. You may want to look that up. That might be free. All right. Running rootless containers. So why do we care about running rootless containers? We care because if somebody decides to break out of a container, right, um, via root, that could be on you or your company. Somebody hacks a container and they have keys to the castle, that could be a problem, right? So it says, but this is somewhat weakens the security of the system if a bug allows an attacker to compromise the container, right? And I got root access and I'm able to do whatever it is that I want to do, right? Let me drop and drag this over to here. Let me, it's copying. I'm going back trying to, okay, it's going to take a minute to copy my Docker stuff. All right, now managing containers at scale. All right. So this gets into Kubernetes, Swarm, probably Rancher, Tanzu, GKE, how do you manage, say you have an application, right? And that application is made up of 40 containers. And each one has their own thing that they do. How do you manage that at a higher level, right? Like how do you manage having 40 little students in the class, right? That's really what that comes down to. So here, deploying containers at scale in production requires environment that it can adapt. The platform must ensure availability. Environment must respond. Environment must be secure. And what they failed to mention here is networking, right? Firewalls and networking. The platform should detect failures. Develop Developers might need an automated workflow, and hence the word Kubernetes and OpenShift. I won't go into those. You can read those on your own. My suggestion to you off of this page is understanding Cgroups and namespaces and setcomp. Right? I would reference those as something that just you just need to know for conversation perspective. Any questions so far? Did I hit next? All right. Well, I won't do this quiz with you because I don't know if you were paying attention or not. Oh, it's not free. All right. So we won't answer these questions. I'm gonna let you all do this. Let's skip on. Let's move ahead. He's like you want to do the quiz, huh? Let's go. Running a basic container. All right. So here they're not on a particular host, but they're just walking through like how to run a container, do again Podman images and pools and so forth. That's what I was working on with my machine here. We're gonna do Docker and we're gonna do Podman. I'm gonna do Docker first, and then I'm gonna go on to their site and do Podman. Your desktop needs privileges. Okay, sure. Give you the keys to the castle. All right, it's coming up. All right. Um, Docker engine starting. Come on, it's still going. Just a different response than what we had before. Okay, getting started. Okay, all right, it should be up now. Okay, so you can see I don't have any images on this box, and right, but there is a container that we can download and run, um, and I want to show it to you. Right, so say you want to play with Jenkins, right? So you could do a Docker pull, or you could just do Docker run at this point and just type in Jenkins. So I don't have it locally. Let me see what they say. Oh, they don't have Jenkins latest. Let me see something. Let me see. Docker pull. Uh, can we pull Terraform? Oh, you know I need to sign in. Hold on. I need to sign in on my box. Let me sign in. I'm signing in. Hold on. Hold on. If I remember it, you. Oh, that's because that was that. Let's see. All right, we signed in. So now that I'm signed in, we do a Docker images again. Nothing. and then we'll do a Docker run Jenkins. Uh, you don't. Oh, well, let's do Docker pull then. I thought it was gonna automatically pull it, but it should have. Oh, they don't have nothing in there anymore. Did they take everything out? Oh, that's so sad. Mm, can I do Hello World? Can you do that now? Full access denied for Hello World. Positive does not. Says Docker login denied. All right. Let me look on here from. Let me do a Docker login locally. Hold on. Even though I signed into the application. Okay. Still don't like me. Maybe I need to find out where another one is. Let me see here. Let me look at my application for Docker. And that's tip of the week. I don't want to start it when I log in. Nothing there. I'm just going through my preferences. I'm trying to get I'm trying to show you the difference between the Docker um mm, Docker login. I mean Docker and Podman. Let me log in here. But that because the commands are gonna look the same. That's why. Looks like I have something up there. I don't know what it is. Let's see. It says I got a thing up there. It says I have a container. Let me look. Let me see if I can get it pulled down. Um, let's see. And okay, yeah. All right, so I have a container up there, and it's called Tamika's Women in Linux 70. Women in Linux in its latest. So as you can see, it's pulling that container, right? All right. So now when I do a Docker images, I have that container. 2 years ago, I don't know what's on that container. So let's do a Docker run dash IT. Tamika, women in Linux, and we could just do ladies. Is that all right? Oh, mm, let's do this then. Let's do a Docker run on this image. I don't even know if it's been bash. It's about to find out though. All right, it's clear. Clear. All right, so we have that Docker image. It's probably a Red Hat image. 7.6, super old. All right. If I do an ls, you can see that. And this also shows how I was able to do a Docker login, connect to my Docker repo or registry that I have, download the Docker container, run the Docker container, and now I can see what's on that Docker container, right? But let's exit this container. And now let's do a Docker PS. But if I do a Docker PS minus A, you can see that it was a container that was ran a couple of minutes ago. And this name is a random name that it gives it. You can give it a name. If you're not familiar with Docker commands, you can do a Docker dash dash help. All right. And it'll give you all the commands uh, for that. Right. So let me clear and let me do a Docker run dash dash help. And so now you can see I get some other commands I can use with my Docker run, right? Suppose I want to name it, right? I can pass the name dash dash string. So all right, so let's clear my screen. Let's use my up arrows because you can do that in Linux without typing in commands. And then I'm gonna do dash dash name. We're gonna call it Tamika, right? And then let's exit. And then let's do a Docker PS minus A. Did it take it? Oh, yeah, see the name right here. See, I named it. So make it easier for yourself. But back in the class, what they're showing here, where's my link? Am I on the wrong screen? I am on the wrong screen. Here it is. This is how I know I had a one up there, right? Like 3 years ago. It's been so. All right, so here I did exactly what they were going to show you with Podman. I did it with Docker. Podman makes a link to Docker commands, right? So we can do a Docker, we can do a Podman pull, and this is a registry we can pull from. This is a Red Hat registry. Here's the path, and here's the tag for that UBI. If you're not familiar with UBI, if you go Red Hat UBI containers, Red Hat has universal base images that they use. Yeah, they're OCI compliant, right? And then they go a little bit more into what they are and so forth. And you can come out here and check out a catalog of stuff of containers, right? You can, if you want different for a different type of processor version and so forth and so on, right? So over here, they're running UBI 8, not 8.4, just 8. But they tagged it with the latest, so it should grab the latest. So the latest may be 8.4. Then they do what I just did. Podman images. We pulled, and we got some images in our on our local box. Now we're gonna run it, and that's what they did here to run it, right? So if you run a container using a fully qualified image name, but the image is not yet stored locally, then Podman run would do a pull first. So that's why you saw me trying to do just a Docker run, because the Docker run should pull from whatever registry and then pull that down. So this may or may not work, but we're gonna give it a shot. I think I may need to log into a registry in order for that to work, but let's give it a shot. Let's do a Docker pull. Let's see if that pulls. Oh, it works. So that's public. So that's freely accessible. So I just pulled down that UBI, right? So now if I do a Docker images, you can see I have, and it tells you the registry that it came out of latest, right? So now I'm gonna do a Docker run dash name dash dash name real UBI, and let's grab this, put a tag on it. Oh, my bad. I forgot my IT. Oh, I forgot one other thing. Then bash. The container is already in use, you have to remove or rename the container in order to reuse it. Let me see something. Docker PS. Oh, there's no container running. Yeah, it all exited. So I think it has to do with how I have this set up, this naming scheme here. I think I have to put this in front. What are you not liking? Oh, yeah. Let's get rid of the name for right now. I don't know why it found it as a name. 8.4. So we verified the latest is 8. Was using 8, and then 8.4 will be the latest. And there you are, a container. So if you want to play around with Linux commands and you didn't want to mess up your system and you didn't want to go through install everything, you can install the latest and greatest of Docker. You can then just really point to that registry that I pointed to, and then now you can say, well, pwd ls cdo with a temp get fackle or get is it fact, right? Yep. You can say chmod. That's there. You could then do a yum. Let me see if we can we have yum dash dash help. Yep, we have yum on there. How about clear? Clear is not found. So clear command is not on here. So I'm just gonna use my up arrow here. I'm gonna exit and then come back in. All right, so clear wasn't on there. It didn't have clear. Echo $shell bin bash. We do environment variables. Here's what's local in my environment. Can I do a yum install of, I don't know, telnet? I just want to see if we get anything. Okay. How about if I do a yum install of nmap? Okay, I can install some packages, right? So you can play around with yum, you can do little stuff. So that's pretty cool, right? So the next thing that they talk about here is we did the run. They said the T is equivalent to the terminal, the I is interactive, the D is for detached. They didn't pass a D here. But if I wanted to do that in a detached format with Docker or Podman, let me exit and let me clear. And let me go back up here and do with the dash D. Right. So now if I do a Docker PS, you can see the container is running. It didn't exit, it didn't crash or anything. It's running, but it's running in a detached format, right? So it's just up and running. So the container is up and running. All right. Now, I'll go back over here. Let's say here I showed you the name, right? We gave the bin bash. We was able to move around in it. Now we can do if we want to run a command, right? So here run dash dash rm follow use podman run dash dash rm followed by the container image and the command. So here we're gonna say, okay, run dash dash rm and then pass this command here, right? Cat etc red hat release. So we can do the same thing with Docker. Let's give it a shot. Let's use our up arrow here. We're gonna Control A back to the beginning of the command line. When it is at dash dash rm. Control E to the end, and let's do a ls minus L on slash temp. Let's double verify dash rm. Yep. Nothing there. So let's do var log. Nothing. All right. How about on slash? Can I do that? Oh, it doesn't like that command, huh? Let's see. What are we missing? Oh, so apparently Docker doesn't have that. All right, so let's do a man on Docker run. Let's do a help on Docker run. Automatically remove the container when it exits. Okay. But we should be able to do this. It didn't like that. Oh, am I doing the bin bash? That's what it is. Yep, I need to get rid of bin bash. Oopsie, my bad. Put my slash in there as if it was continuing on to a new line. But if I go back up now, let's go back and do the ls minus L on var log and get rid of bin bash. That was the problem. You can see I get my log file. So if I go here, yeah, what is under RHSM? Nothing. Okay, but if we can do it ls minus L on slash, and so we're returning what's there in slash, right? Cool. All right, so you can see there's some similarities between Docker and Podman. Now here, the analyzing the container isolation, we're gonna run and we're gonna view the processes running inside. That's the px minus aux. You can see the bin bash should give you a shell that hop in there. We can run id, right? And then they have more documentation here. All right, and then you have an exercise that you need to do, and you're hopping on workstation. Well, workstation, you run this command, and then hop on workstation, SSH to this machine, or open up that machine, and then start using the module install of containers. Log into the registry like I did with a Docker login. You're logging into a registry. And then we do a pull, a Podman pull. And then here we can say, hey, I'm giving it a name. I want to use it interactively. I want to then use this particular Docker container, right? Or container. And then use bin bash. Here, run this command, run that command, exit. Now it's saying we're going to run a command and then delete it. So we're gonna run it, delete it. The command we're running is httpd with a -v on it. Exit and finish up and clean up the lab, and you're done. All right. And then finding and managing container images. So here they're getting into the registries, the different registries. So you can use insecure registries or secure registries, but you need to specify that it's unsecure. And this is what this particular file is used for, to specify the registries and whether or not it's secure or unsecure. And they tell you what registries to pull from, to look for, to look in to pull my Docker container. For a regular rootless user of Podman, this file is stored in home.config configuration settings. It is file overrides system-wide ones. Okay. So here they're just saying do a Podman info to give you like, hey, what registries are you currently configured for? And here, this is where I was talking about insecure registries right here, right? In that registry.conf file. And now they're saying Podman search this registry and tell me what's in it, right? So here, use Podman search to command to search all the that registry, this particular and give me all the images in that registry that include the name rel 8, right? That's we need to specify that because here's the registry and here's what you're looking for in that registry. So everywhere there's an occurrence of rel 8, right? Right. And then it says, well, don't truncate the information. Give me all of it, right? Give me all the information. That's kind of wordy. And then they give you options like you can list, you can limit the list, you can filter. Here, where we're saying here, disable because you may have a registry set up and you don't have it in that file to be insecure or whatnot. So you can disable TLS, right? Right. And then here we're doing an inspection. So here's the inspect. So now we switch commands, right? Before we switch commands, does what we went over, does it make sense so far? I see some people left.
Yes.
Okay. All right. All right. So now when we inspect the container, why are we inspecting the container? Why do we care to inspect it? And why do we care to inspect a container? All right. So you can view information about an image before downloading it to your system because you can run a container and it has some kind of virus or something on it that spins up at runtime. Just people are crafty, right? All right. So here, let's the I guess I don't know why I want to call it skew, just but SKOPEO Scopio
Mm-hmm.
is inspect command can inspect different image formats from different sources such as remote and local registries. The Docker :/ transport mechanism instructs Scopio to query a container image registry. So inspect this Docker registry, rel 8, Python 36. Give me some information about it, right? And then it says you can also inspect locally. So we got Podman images, and then we're going to inspect again the registry, Python 36. And because we tagged it with latest, it's just going to look at the latest. But if you tagged it with V1 or V2, you have to put a colon on the end and change that to V1 or V2. And then removing local containers, we got Docker images, the good old fashioned RMI, remove image, right? And then show your Podman images, right? So the key takeaway out of this section is inspecting the container before you download it, right? I don't know what that will be inside of Docker if you were doing Docker commands, how to inspect. I will have to look it up to inspect the container in a remote registry. I have to look that up. All right, let's go next. All right, so here is the lab. They're gonna walk you through setting up the lab, as you can see up here, and they walk you through some inspecting a login, searching the actual registry, configuring the registry, show me some images, inspect something before you download it, remove, see that it's removed, and then exit. See where we at. We're not gonna make through all of it, but let's stop here. So I don't think we're gonna make it through all of this. Yeah, we're not gonna make it through all of this. We'll end up going over. So when we come back, you have some time to catch up to here. Let me look at the table of contents here for chapter 13. All right, so we're here. The next thing that we're going to do is perform advanced container management. We're going to do assisted. We're going to persistent. We're going to attach some storage. We're going to manage containers as services, and then there's a guide exercise. And let's go look at managing container as a service. Here's the. Let me scroll up here. System D is what you're looking at, right? So we'll dive into this the next time we meet. I may try to go live with this part here. I may try to go live with this part. Yeah, I may try to go live with this so that way we don't have to wait 2 weeks, and then I'll go back over it again. All right. So we're halfway through. It's almost done. And then you got the lab for running containers, persistent storage. Yeah, we'll have to read through this. We'll do that. We'll do Podman and Docker container attaching storage on both, so you get a chance to see what it looks like for attaching storage containers. Attaching storage to a container and then inspecting what's in the storage, right? All right. Being able to say, okay, what's in that storage? Let me throw something in there, and the storage is from the host operating system. Remember, when you're talking about storage can be local, it can be remote as well, right? So maybe it's some remote storage that we attach, or some local storage that we attach to it. Cool. All right. Let me stop recording.